Hello friends, so this is my first lecture in your college. So I will introduce myself. Myself is Professor Dute BB, working as Associate Professor and Head Department of Mathematics, RNC Arts and Aerobic Science and JDP Commerce, NSC Science College, Nashik Road, Nashik. In this academic year, I will teach you Calculus Paper 2, Calculus 2, Mathematics Paper 2, whose code is MT122. And in this course, we are going to study concept of differentiation, which is Unit 1, then L'Hospital rule and successive differentiation. You are also well familiar with successive differentiation. You have studied that in 12th standard, differentiation from 11th and 12th standard. Then other topic is ordinary differential equation. So you are also familiar with differential equation. So first order differential equation, in which variable separable form, homogeneous differential equation, and then non-homogeneous differential equation reduced to the homogeneous differential equation. That type of you are solved in 12th standard, and exact differential equation. So for this differentiation and L'Hospital rule, we will use the book by R.G. Bartle, D.R. Sedward, John Wheatley and Sons publication, 4th edition, Introduction to the Real Analysis by Bartle and Sedward. While topics ordinary differential equation and exact differential equation, we will cover those topics from Differential Calculus by Shanti Narayan, 10th revised edition, and Elementary Differential Equation by William F. Trench, which is an e-book. Free download is available for it. So today I will start unit number 1, which is nothing but differentiation. So you have studied the real variable function of real variable, which is called as the real function, and then limit of function in neighborhood of a defined at a, continuity and derivative of one variable function at a point. So revise a definition of derivative, its geometrical meaning, left hand derivative, right hand derivative, etc. Okay. So what is definition? If y is equal to fx is defined in neighborhood of a, real function defined in neighborhood of a, then f is differentiable, then f is the differentiable at a if limit extends to a of fx minus fa upon x minus a, or limit extends to 0 f of a plus h minus fa upon h exist. Then we say that it is differentiable at a. So firstly it must be defined in neighborhood of a. Means values of fx must be defined on left side of A as well as right side of A. Right side of A. Now definition depends on limit. So this limit, if exist, then we say that it is differentiable at A. Okay. And we will denote this derivative by f dash A is equal to f dash A is equal to this. Okay. Left hand derivative at A. Derivative at A. If f is defined in left neighborhood of A, okay. If y is equal to fx is a real function, defined in A minus delta to A for some delta greater than 0, then f has left hand derivative such that then left hand derivative of A, left hand derivative of A of f at A is f dash A is equal to f dash A minus A is equal to limit h tends to 0 plus, or h tends to 0 minus f of A plus h minus f A divided by h. If h is very near to 0 from left side, h if exist, or this is nothing but limit x tends to A minus f of x minus f of A divided by x minus A. See here, h approaches towards 0 from left side, means x approaches towards A from left side. Is it clear? So if this exists, then we denote by f dash of minus A is equal to this. Okay. Similarly, right hand derivative. Of f at A. If y equal to fx is defined in neighborhood of A to A plus delta for some delta greater than 0. In neighborhood of A, that is in neighborhood A minus delta to A plus delta of A. Then f has right hand derivative at A if f dash plus A is equal to limit h tends to 0 plus of f of A plus h minus f A upon h. This is same as equivalent to limit x tends to A plus fx minus fa upon x minus A is nothing but h. If exist. If this limit doesn't exist, then we say that it has no right hand derivative. If this limit doesn't exist, then it has no left hand derivative also. Okay. And if If it is differentiable at a, then f dash plus a, f dash minus a must exist. F dash plus a as well as f dash minus a must exist. Okay. So note, if f is differentiable at a, if f is differentiable at a, then f dash a is equal to f dash plus a is equal to f dash minus a. Left hand derivative and right hand derivative are equal. Okay. Second, if f dash plus a not equal to f dash minus a, then f is not differentiable. Then left hand derivative, right hand derivative are not equal, means this limit must not exist. This limit doesn't exist. Okay. Then f is not differentiable at a. Not differentiable at a. Now, what is geometrical meaning of this? Geometrical meaning. Geometrical meaning. If y is equal to fx, is function whose graph is like this, and here I have some point a here, this is y equal to fx function. I will take h just to be positive. This is your a plus h. Is it right? This PQ is second, AFA, and this is Q, A plus H, F of A plus H. So from figure, from diagram, slope of second PQ is equal to f of a plus h, difference between y coordinate upon difference between x coordinate, a plus h minus a get cancelled. As q tends to p along curve, as it tends to 0, Q tends to P along curve. Okay, so if I will take here Q dash point, right, and so on Q dash, and lastly we will get here. Right, along curve. Then PQ tends to tangent to curve at P. Okay. So therefore, f dash a is equal to limit h tends to 0 of f of a plus h minus fa upon h. This is nothing but slope of tangent. Slope of tangent to curve at P. At P. So what tangent PT will become at P is slope is nothing but this one, which is exactly f dash a. Which is exactly f dash a. Means geometrically, if I have such type of okay, again for this point where angle is formed, at that point you cannot draw the tangent. At that point you cannot draw the tangent. Therefore, as tangent doesn't exist, therefore this limit cannot exist at that type of point. So on the curve, if there is an angle formed, then that function has no derivative at x coordinate of that point. So this geometrical meaning is very, very important for us. For example, if I take mod x, this fx is nothing but mod x. Y equal to x line here, and this is minus x. There is angle formed here. So fx equal to mod x must not be differentiable at 0. Its left hand derivative, right hand derivative must be different. Must be different. Is it clear? So geometrically, what is f dash a? It is nothing but slope of tangent to the curve y equal to fx at P a f of a. And if that tangent doesn't exist, then geometrically function is not differentiable at point. And that points are nothing but those points where angles are formed on the curve. Okay. So you have to identify geometrically points where angle is formed. So take example or note y equal to fx is a differentiable function of x, is differentiable function of x if f dash x is equal to limit h tends to 0 f of x plus h minus fx upon h exists for each x belongs to domain of f. That is your f dash x. So if you find derivative of this fx function with help of this, so this is known as definition of derivative. And if you evaluate derivative of fx via this concept, then it is known as, we will find derivative by using first principle. Okay, first principle. Example, find fx, find f dash x. So first one, fx equal to say x raised to m. f dash x is equal to limit n belongs to n, say. We'll take n belongs to n. N belongs to n. So limit h tends to 0 of f of x plus h minus fx upon h. So what will get? Limit h tends to 0 of x plus h raised to n minus x raised to n upon h. Now expanding this by using binomial expansion, we will get this to be limit h tends to 0 of x raised to n plus n into x raised to n minus 1, right, nc1 into x raised to n minus 1 h plus nc2 x raised to n minus 2 h square plus so on, plus last term is h raised to n minus x raised to n upon h. So this x raised to n get cancelled, and by taking h outside, limit h tends to 0 of nc1, if I take h outside, h in bracket, this nc1 x raised to n minus 1 plus h times nc2 x raised to n minus 2h plus dot dot etc. plus h raised to n minus 1. Every other term contain h. This h get cancelled since h not equal to 0. So I can cancel h. By applying the limit, so all other terms become 0. So we'll get this equal to nc1 into x raised to n minus 1 plus zeros, right. nc1 is n, so n into x raised to n minus 1. Since your nc1, ncr is equal to n factorial upon r factorial into n minus r factorial, which is same as nc n minus r. nc n minus r. So in this way, we have evaluated limit of this, delta of this. Okay. Therefore, dy dx of x raised to n is equal to n into x raised to n minus 1. Okay. N belongs to m. So note, dy dx of x raised to n is equal to n into x raised to n minus 1 for n belongs to q also. N belongs to q. If I take negative number also, it is true. It is true. This formula is true. So if you want to verify by using definition, you can try it for it. In fact, for rational power, it is also true. Real power, it is true. Okay. Now we'll take formula for sin x. Second example, fx is equal to, say, a raised to x, a greater than 0. F dash x is equal to, by definition, what will get? Limit h tends to 0 of f of x plus h minus fx divided by h, which is equal to limit h tending to 0 of a plus a raised to x plus h minus a raised to x divided by h, which is equal to limit h tending to 0 of a raised to x into a raised to h minus a raised to x upon h. Now, if you take your a raised to x outside, which is nothing but limit h tends to 0 of a raised to x in bracket a raised to h minus 1 upon h a raised to x into limit h tending to 0 of a raised to h minus 1 upon h, and you have taken this to be log a. This is your log a, right? So this is a raised to x into log a. Is it clear? So this is the formula for limit of derivative of this one, means d by dx of a raised to x is a raised to x into log a. So with this discussion, we'll stop here. For more practice of definition or by finding derivative by using first principle, you can use your 11th standard mathematics book, 12th standard mathematics books, and you can take simple expression to differentiate with help of definition. And recall all formulas what you derived by using definition. Okay. So it is just revision. For us, geometrical meaning is very important to find point on the curve at which function is not differentiable. So, thanks for listening lecture carefully. Bye bye.